this video, we're going to be differentiating according to the chain rule. In the chain rule, you're always going to have something that can be written as a composite function. So notice that I don't have e to the x, I've got e to the x squared plus 1. And I don't have the square root of x, I have the square root of something more complicated. So we're always going to have a chain. Now, what we'll always do is we'll talk about each of these functions where we're breaking it up as y is a function of z, z is a function of x, and to find dy dx, we'll take dy dz times dz dx. So let me show you how we're going to do this for the first problem. In A, we've got y equals e to the x squared plus 1. We're going to write this as a composite function. The z always stands for your inside function. So that's what's inside parentheses, what's in a square root, what's in a denominator, what's in an exponent. So the best thing to do here is to go with z is what's in the exponent. So that's x squared plus 1. And then y equals e to the z. So it's chain rule time. dy dx equals dy dz times dz dx. I want to multiply the two derivatives together. What's the derivative of e to the z? That's e to the z. What's the derivative of x squared plus 1? That's 2x. Note that I have a z in this expression. Got to get rid of it. No z's when we're done. So the answer is e to the x squared plus 1, because that's what z is, times 2x. In class, you'll hear me describe this as the derivative of e to the blah is e to the blah times the derivative of blah. That's exactly what happened here. We have e to the blah times the derivative of the exponent. Okay, let's do some more. Let's do B. In B, I have y equals, and of course we don't like square roots, we like fractional exponents instead. So that's 3x minus 2 to the 1/2 power. Again, what we have to do is we have to talk about a y and a z. So the z will be what's on the inside, that is 3x minus 2. And then in that case, y is z to the 1/2 power. So we need dy dx equals dy dz times dz dx. So I look at my derivatives. Dy dz, the derivative here, that's just using the power rule. 1/2 z to the negative 1/2 times dz dx. What's the derivative here? That's just 3. I've got a z, can't have a z in there. So this is going to be 1/2 3x minus 2 to the negative 1/2 times 3. So note, what happens is the derivative of blah to the 1/2 is 1/2 blah to the negative 1/2 times the derivative of blah. All right, one more time. So for the last one, let's take y equals 10 times e to the x. And again, I have to figure out what's my inside function. Well, that's an exponent in this case, so that'll be e to the x. And y will be 10 to the z power. So, dy dx equals dy dz times dz dx. dy dz means I'm taking the derivative of this exponential function. So I will get the natural log of 10 times 10 to the z. dz dx is the derivative of e to the x. We love e to the x. It's just e to the x. I can't have the z in there. So this is going to be the natural log of 10 times 10 to the e to the x times e to the x. So in this case, the derivative of 10 to the blah is natural log of 10 times 10 to the blah times the derivative of blah. And those are three examples of the chain rule.